We are starting with the extra problem set 2. Okay, so the first problem is something like this: 0 to a x raised to 4 upon root of a square minus x square dx. Now there is a minus sign over here and there is a over here. Okay, yes, of course, if you apply that 0 to a property, you will not get the same denominator. You can try, you will definitely not get it. Okay, so we'll put x is equal to a sine t. You can also put x is equal to a cos t. Okay, you cannot put x is equal to a tan t because there is minus sign in between. So such type of problems you have done in one of the exercises of differentiation. D by dx of x is equal to d by dx of a sine t. Okay, so d by dx of x is 1, a is outside, d by dx of sine t is cos t into d by dx of t, chain rule. Okay, so dx, this will give you dx is equal to a sine t dt, a sine t dt. So this is sorted, right? Also, we'll try to find out the value of root of a square minus x square. So root of a square minus x square is equal to a square minus a square sine square t. Okay, because x square will be a square sine square t. Just a second, I'll just change this. Dx is equal to a cos t dt, right? So this will be root of a square 1 minus sine square. So a square cos square t, which is equal to a cos t. Now x is equal to a sine t. X is equal to a sine t. X upon a is equal to sine t. Therefore, t is equal to sine inverse x by a. Now put the value of x as the lower limit is 0, and the upper limit is a. So t is equal to sine inverse 0 upon a, which is sine inverse 0, that is 0, and sine inverse a upon a. Sine inverse a upon a is sine inverse 1. 1 is 90. So 0 to pi by 2. So I is equal to 0 to pi by 2 x raised to 4. So x is a sine t raised to 4. Down we have got a cos t, right? That is the value of root of a square minus x square a cos t, and dx is equal to a cos t dt. A cos t dt. Fine. Okay, so a and a is getting cancelled over here. Cos t got cancelled. So this will be a raised to 4 sine raised to 4 dt, 0 to pi by 2. Fine. Okay, now sine raised to 4 and cos raised to 4, try and understand how to solve this. 0 to pi by 2 sine square t the whole square dt. Okay, now within the round bracket we'll multiply and divide by 2. So a raised to 4 2 sine square t upon 2 dt, 0 to pi by 2. So the whole square. So a raised to 4 by 4. So this 2 square I'm taking out, and then this will be 4. Sorry, 2 sine square t will be 1 minus cos 2t raised to 4. 0 to pi by 2. Okay. 1 minus cos 2t raised to 2. Now expand this. A raised to 4 by 4. Okay. 1 minus 2 cos 2t uh, plus cos square 2t, 0 to pi by 2 dt. Now again we'll multiply and divide by 2 over here. A raised to 4 by 4, 1 minus 2 cos 2t, 2 cos square 2t by 2, multiplication and division by 2 because it's square. A raised to 4 by 4, 0 to pi by 2, 1 minus cos 2t plus 1 minus sin 4t upon 2. Okay, so I use half angle over here. 1 plus cos 4t, because 1 plus cos 2x is 2 cos square x. So 1 plus cos 4x is 2 cos square 2x. Okay, I'll take LCM within the box bracket. A raised to 4 by 4, 0 to pi by 2, 2 minus 4 cos 2t plus 1 plus cos 4t upon 2. So A raised to 4 upon 8. 4 2s are 8. This 2 is multiplied with this 4. 0 to pi by 2, 2 plus 1 is 3 minus 4 cos 2t plus cos 4t dt. So this is going to be A raised to 4 by 8, 3t minus 4 sin 2t by 2 plus sin 4t by 4. This 2 and this 4 is due to the chain rule. Okay, and the limits are 0 to pi by 2. So this is 2 ones are 2, 2s are. Now in place of t, we are going to put pi by 2. And in the second bracket, in place of t, we are going to put 0. So A raised to 4 by 8, box minus box. Okay, 3 into pi by 2, that is 3 pi by 2 minus 2 sine 2 pi by 2. So that is become 2 sine pi plus sine 4 into pi by 2. Okay, so that will be sine 2 pi. Okay, and the second bracket, let's put 0 everywhere, wherever there is t. So 3 into 0, that is 3 into 0 minus 2 sine 0 plus sine 4 0. 4 into 0, that is 0. Second entire bracket is going to be 0 because sine 0 is 0. Now sine 180. Sine 180 is also 0 and sine 360 is also 0. So this will be A raised to 4 by 8 into 3 pi by 2. Okay, so 3 A raised to 4 pi upon 16. That is your answer. Okay, so this type of problems requires a lot of patience. Okay, and some basic knowledge of integration as well. Integration of 0 to a sine inverse root of x plus a upon x dx. So put x is equal to a tan square theta or tan square t, because there is plus over here. And we need to put square because x is x, it's not x square. Okay, so d by dx of x, d by dx of a tan square t, a outside. So 1 is equal to a outside x raised to n into dy dt of dy dx of tan t, chain rule. First it is x raised to n formula, n into x raised to n minus 1. Now tan t derivative is sec square t So this is 2a tan t into sec square t, d by dx of t, because it's chain rule, right? Once again, we are differentiating with respect to x, not t. So this is x. Fine. So dx is equal to 2a tan t sec square t dt. Fine. Now changing the limits, x is equal to a tan square t. Therefore, x upon a equal to tan square t. Therefore, tan t is equal to root of x upon a. T is equal to tan inverse of root of x upon a. Okay, so t is equal to tan inverse of root of x upon a. Now two things, x is 0 and x is a. So when x is 0, 0 upon a, that is 0, tan inverse root of 0, tan inverse 0, which is 0. And a upon a is 1, root of 1 is 1, so tan inverse 1 is 45, pi by 4. You can put the values and check. So this will be integration 0 to pi by 4. Okay, sine inverse x is a tan square theta, right? And down a plus a tan square theta. And dx we have calculated, dx is 2a tan t sec square t, 2a tan square t sec square t dt. So I is equal to 0 to pi by 4 sine inverse a tan t, take a common, 1 plus tan square t, 2a tan t sec square t dt. 0 to pi by 4 sine inverse a is getting cancelled. So this is root tan t upon sec square t. One second, is I'll just go back. A is tan square theta. Okay, so I just made that mistake. Yeah, so the root goes, this is sec square t, 1 plus tan square t is sec square t. The root of sec square t is sec t. Okay, and this is going to be 2a tan t sec square t dt. So 0 to pi by 4 sine inverse. I'll take this 2a outside. That's not required anymore within the integration. This 2a sine inverse tan t upon sec t. So tan t upon sec t is sine t. You can convert into sine and cosine check. And this is tan t sec square t dt. So sine inverse and sine is gone. So t tan t sec square t. 2a 0 to pi by 4 t tan t sec square t. Okay. So now what we'll do is we'll again put tan t is equal to p, because the derivative of tan t is sec square t. This time it will be d by dt, because the left hand side variable is t. D by dt of p sec square t dt is equal to dp by dt. Therefore, sec square t dt equal to dp. So this became dp, this is p. But then what about this t? So t will be, see now, p is equal to tan in, just a second, tan t is equal to p, therefore t is equal to tan inverse p. Okay, also now we have to change the limits once again. P is equal to tan t, t is equal to 0, t is equal to pi by 4. So when t is equal to 0, p is equal to tan 0, which is 0, p is equal to tan pi by 4, which is 1. So 0 to 1. Okay, so this will be integration of 0 to 1. Okay, t is tan inverse p. Which t I'm speaking of? I am discussing this t. So it is tan inverse p. Okay, sec square t dt is dp, and this is p. So this is p dp. Now this is ITF and this is algebraic u and v. You can solve this further using u and v. Fine. So it's a proper 6 marker. You have to uh, keep on solving. Multiple things are there in this problem, right? You can try from this particular point and get the solution. Integration of 0 to pi by 4 root of tan x plus root of cot x dx. 0 to pi by 4 root sin x upon root cos x root cos x upon root sin x. 0 to pi by 4, this will be sin x plus cos x upon root sin x into cos x. Okay, I took LCM and then this into this. Roots can be multiplied. Okay, so I'll just write this on the next page. I is equal to 0 to pi by 4 sin x plus cos x upon root sin x cos x. Okay, now guys, we have done this problem in the previous session also, such kind of problem. Sin x plus cos x is derivative of what? Of which term? That we need to understand. Cos is the derivative of sine, and sine is the derivative of minus cos, because cos derivative is only minus sine. Cos derivative is minus sine, so minus cos derivative will be sine. Okay, so put sin x minus cos x is equal to t. D by dx of sin x minus cos x, d by dx of t. Sin x minus cos x is cos x plus sin x, derivative dt by dx. Therefore, sin x plus cos x dx is equal to dt. Sin x plus cos x dx is equal to dt. Okay, 1 upon root of sin x cos x. Now we are going to solve this separately. We'll go to the previous slide once again. So sin x minus cos x is equal to t. So I'll square both the sides. Sin x minus cos x, the whole square is equal to t square. So sin square x plus cos square x minus 2 sin x cos x is equal to t square. So 1 minus 2 sin x cos x is equal to t square. So 1 minus t square is equal to 2 sin x cos x. Therefore, sin x cos x is equal to 1 minus t square by 2. So we got the value of root. Okay, this we got. So sin x plus x is 1 minus t square by 2. Correct. Also, we have to change the limits because we have done method of substitution. So t is equal to sin x minus cos x equal to 0, x equal to pi by 4, x equal to 0, x equal to pi by 4. So t is equal to sin 0 minus cos 0. Sin 0 is 0, cos 0 is 1. So t is minus 1 and t is 0. Okay, because sin 45 minus cos 45. So this is going to be minus 1 to 0. Okay, now this 2 will go up in the numerator, but then it will go as root 2 and I can take it outside the integral. Okay, minus 1 to 0. Denominator becomes numerator. Now this is a direct formula, guys. Sin inverse t. Okay, so root 2 curly bracket box minus box sin inverse 0 sin inverse minus 1. Sin inverse 0 is 0. Okay, sin inverse 0 is 0, this part. And sin inverse minus 1 is minus sin inverse 1. And already there is a minus sign in between. So this is going to be plus. So sin inverse 1 root 2 plus, sorry, into sin inverse 1 is 90, 90 is pi by 2. So root 2 pi by 2. That is your answer. Okay. Next problem. I'll just give the hint for this problem. I'll not solve it entirely. E raised to 2x sine pi by 4 plus x dx. Okay. So first step is to reverse and then solve using light integration by parts. But then see, there are many terms. You have to proceed very systematically. If you're not proceeding systematically, then you might not get the right answer. Okay. So it's a recursive function. You might have understood by this time that it's a recursion. Let's go to the next problem. We'll be interested to take some modulus based problems over here with respect to trigonometric functions. Okay. Yeah. So be more attentive now. So these are some modulus based problems which might trouble you. So let's take a few. Sine of modulus of x dx. Now see, modulus of x inside whatever value x is there, it can be positive or negative. Okay, so minus pi by 2 to pi by 2 sine of positive or negative x dx. Okay, so minus pi by 2 to pi by 2 sine of positive x sine of negative x dx minus pi by 2 to pi by 2 sine x. Okay, now see, I'll just stop over here. Here we'll try and understand few things. Now our interval is from negative pi by 2 to pi by 2. So from here to here. So now in the first quadrant, sine is always positive. So it is going to be sin x dx from 0 to pi by 2. Okay, so from 0 to pi by 2, it is going to be sin x dx. And from minus pi by 2 to pi by 2. From minus pi by 2 to 0, which is the fourth quadrant. Okay, so this is the fourth quadrant. In this quadrant, sine is going to be negative. And you all know that sine minus x is minus sine x. Okay, so from minus pi by 2 pi by 2, which is the fourth quadrant, sine is going to be negative. And at the same time, sine minus x I have written as minus sine x. So this is the tricky part. Okay, so 0 to pi by 2 sine x dx plus into minus is minus pi by 2 to 0 sine x dx. So minus cos x 0 to pi by 2. Okay, because the integration of sine is minus cos, and this is also minus cos with a minus sign in between. But then this is going to be minus pi by 2 to 0. So box minus box minus box minus box. So minus cos pi by 2 is 90, minus cos 0, and minus cos 0 upper limit, minus cos minus 90, cos minus 90. Okay, now see this entire thing very clearly. Cos 90 is 0, and this cos minus 90, see cos minus 90 is cos 90, which is 0. Okay, because cos minus x is cos x. Now this minus and minus is plus, and this is going to be 1. This minus and minus is plus, and this is going to be 1. So the answer will be 1 plus 1. The final answer is going to be 2. Okay, yeah. Second modulus problem. There are a variety of these questions which I will cover up right now. Modulus of sine x dx. Now this time the modulus is given for sine x, and the interval is from 0 to 2 pi. So 0 to 2 pi means all four quadrants. 2 pi comes back to 0, right? 360 degrees. So all four quadrants we have to discuss. Now this sign is positive in the first and second quadrant, and it is negative in the second and third quadrant. So plus sine x 0 to pi from here to here, 0 to pi minus sine x. Sine is going to be negative from sorry, pi to 2 pi. Okay, now this minus into plus is minus sin x dx 0 to pi minus pi to 2 pi sin x dx. Now sin x is minus cos x 0 to pi, and this is also minus cos x 0 to pi. Okay, now you can do box minus box and solve this further and get the required answer. Okay, we have done this problem. Uh, we have done this thing in the previous problem. Okay, so you can just solve it on your own. Okay, now they are also asking in one of the problems that what is 0 to 2 pi cos x? Okay, 0 to 2 pi cos x. Modulus of cos x. Now see, 0 to 2 pi is all entire four quadrants. So cos is positive in the first and fourth, and it is negative over here. Okay, so this is 0, this is pi by 2, and let us take this as minus pi by 2. So cos is positive in the first and the fourth quadrant. So minus pi by 2 to pi by 2, cos is going to be positive. Okay, and from here to here, it is going to be negative minus cos x dx. That is from pi by 2 to minus pi by 2. Okay, right? So plus into minus is minus. So minus pi by 2 to pi by 2 cos x dx plus just a second now. See, I will like to make some changes in this problem because in the limits. Let's not take this until and unless it is mentioned in the question. It is not mentioned in the question, the negative value. So we'll not take this as minus pi by 2. We'll take it as 3 pi by 2. Okay. So otherwise the entire solution will go wrong somewhere. So until unless a negative pi by 2 is not mentioned, don't take it as negative pi by 2. Okay. So this is 3 pi by 2. For simplicity purpose, I'm taking. So this is the first quadrant, 0 to pi by 2. Cos is going to be positive. Okay. From pi by 2 to 3 pi by 2, cos is going to be negative. This is pi by 2 and this is 3 pi by 2. And again in the fourth quadrant, from 3 pi by 2 to 2 pi, cos is going to be positive. Cos is going to be positive. Okay. Now minus into plus is minus, and then these three individual integrations you can solve. Okay. So remember one thing, if minus pi by 2 is not mentioned in the problem, don't even touch it. Fine. So that's my suggestion to all of you. Yeah. Now one more problem. Integration of 0 to pi by 2 modulus of sin x minus cos x dx. Now see, this is also a very typical problem. I will address this. It's only from 0 to pi by 2. Okay. Uh, just a second. Yeah. 0 to pi by 2. Now there are two terms, sin as well as cos within the modulus. So I'll do this thing first. Sin x into 1 by root 2 minus cos x into 1 by root 2 into root 2. So basically, I'm multiplying and dividing by root 2. Okay. And then this is cos 45 and this is sin 45. That was the reason. So 0 to pi by 4 sin x cos 45 minus cos x sin 45. Okay. Into root 2 dx. So 0 to pi by 4, pi by 2. Sorry, not pi by 4. Sin x minus pi by 4. Sin x minus pi by 4 and root 2, I'll just write it over here, dx. Now this is a sine term and 0 to pi by 2 is the first quadrant. So this entire thing is going to be positive only. So no need of taking this negative. So integration, root 2 will go outside. Sin x minus pi by 4 dx, 0 to pi by 2. We are only discussing the first quadrant, so sign is always positive over there. So when it comes outside the modulus, it is going to take positive sign. Minus cos x minus pi by 4 upon dy dx of x minus pi by 4, which is 1, 0 to pi by 2. Now by formula it came negative. Okay, minus root 2 cos x minus pi by 4, 0 to pi by 2. So minus root 2 minus root 2 box minus box. Okay. So cos pi by 2 minus pi by 4, cos pi by 2 minus pi by 4, and cos 0 minus pi by 4. Okay, minus root 2. Cos 90 minus 45 is 45, and this is cos minus 45. Now we all know cos x is equal to x. Cos x is equal to x. Okay, so cos x is x. So this is also going to be cos 45, and this is also 1 by root 2. So the answer will be 0. Just a second, let me check whether I have copied something wrong. 1 by root 2 cos 45 minus cos x. Cos 45 sin 45. uh, Sin cos cosine x minus 45 root 2 outside. Okay, sine became minus cos minus root 2. Okay, 90 minus 45 minus cos 0 minus 45. Seems to be correct. I think fine. So you can take this as the solution. So one last problem we will continue in this particular session. This is the problem sine of modulus of x plus cos of modulus of x minus pi by 2 to pi by 2. Now, first of all, this is minus a to a. We can test for even and odd functions. So f of x is equal to sine of minus x plus cos of minus x. So f of minus x is sine of minus x plus cos of minus x, which is equal to sine x plus cos x. Okay, which is equal to sine x plus cos x. Okay. Now see, this is not f of x because there is modulus over here. So I think don't try to go ahead with the even and odd functions. We'll do this problem in the similar way which we had solved earlier. The first problem for modulus. Let me go back to that problem and show you the thing. Yeah, this problem. Okay. So in similar manner, I'll try to do this. So minus pi by 2 to pi by 2 sine of plus x plus sine of minus x cos of plus x plus cos of minus x. Okay. Now this is going to be sine x. This is going to be minus sine x. And these two are definitely going to be cos x. Cos of minus x is also cos x. Okay. Now it is minus pi by 2 to pi by 2, fourth and first quadrant. So in the fourth quadrant, sign is negative. So this is for the quadrant number 4. This is for quadrant number 1. And cos x both are positive. Okay, both are positive. So obviously it is for both the quadrants from that is 1 and 4. Okay, so it is going to be entirely from minus pi by 2 to pi by 2. We can take entire. And at the same time, we can add this 2 cos as 2 cos. So I just write the next step. Integration 0 to pi by 2 sin x dx plus minus pi by 2 to 0 minus sin x dx. Okay, so the first and fourth quadrant solutions are cos of plus x is x, so minus x is also cos x. Both are positive. Uh, from minus pi by 2, that is first quadrant forward positive. I'll take 2 cos from minus pi by 2 to pi by 2. So sin cos x, sorry, minus cos x 0 to minus pi by 2, 0 to pi by 2, minus, first into minus is minus cos x minus pi by 2 to 0, 2 outside, cos x. So I just lost that connection in between. Okay, sorry. So sin x is 0 to pi by 2. This was the first quadrant solution for sine. Fourth quadrant solution for sine. Okay, and 2 cos x. First as well as fourth for cos. So sine is minus cos 0 to pi by 2. Minus into plus is minus. Again, this is cos. So minus pi by 2 to 0. This is for the fourth quadrant. Okay. And this is for first as well as fourth quadrant for cos because cos is positive. Okay. So 2 sin x minus pi by 2 to pi by 2. Okay. Now this is box minus box minus cos 90 minus, again there is minus. So 2 times minus going to plus plus cos 0 minus cos 0 minus cos minus 90. Cos minus 90 is cos 90 plus 2 sin 90 minus sin minus 90. Okay. So see, cos 90 is 0. So this is gone. Okay. Cos 0 is 1, 1 minus 1, 0. So this is also gone. So we are left with this 2 sin 90 minus sin minus 90. 2 sin 90 minus sin minus 90. 2 sin 90 plus sin 90 because sin minus x is minus sin x and this is 1 plus 1, 2 into 2, which is 4. So do this modulus problems also very clearly. Okay, this 3, 4, whatever I've solved, do it very clearly. Fine. Okay, thank you.